Hi, in this occasion I'm going to talk about white spaces as a launchpad for the Internet of Things. What is the Internet of Things? The Internet of Things is an environment in which objects, animals or people are provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. Internet of Things has evolved from the convergence of wireless technologies, microelectromechanical systems, and the Internet. A thing in the Internet of Things can be a person with a heart monitor implant, a farm animal with a biochip transponder, an automobile that has built-in sensors to alert the driver when tire pressure is low, or any other natural or man-made object that can be assigned an IP address and provided with the ability to transfer data over a network. So far, the Internet of Things has been most closely associated with machine-to-machine communication in manufacturing and power, oil and gas utilities. Products built with machine-to-machine communications capabilities are often referred to as being smart. IPv6's huge increase in address space is an important factor in the development of the Internet of Things. The address space expansion means that we could assign an IPv6 address to every atom on the surface of the Earth and still have enough addresses left to do another 100 or more Earths. Um, in other words, humans could easily assign an IP address to everything on the planet, and increasing the number of smart nodes as well as the amount of upstream data the nodes generate. This is expected to raise new concerns about data privacy, data sovereignty, and security. Today computers, and therefore the Internet, are almost wholly dependent on human beings for information. Nearly all of the roughly um, 50 petabytes of data available on the Internet were first captured and created by human beings by pressing a record button, taking a digital picture, or scanning a barcode. The problem is people have limited time, attention, and accuracy, all of which means that they are not very good at capturing data about things in the real world. If we had computers that knew everything there was to know about things, using data they gathered without any help from us, we would be able to track and count everything and greatly reduce waste, loss, and cost. We would know when things needed replacing, repairing, or recalling, and whether they were fresh or past their best. Although the concept wasn't named until 1999, the Internet of Things has been in development for decades. The first Internet appliance, for example, was a Coke machine at Carnegie Mellon University in the early 1980s. The programmers could connect to the machine over the Internet, check the status of the machine, and determine whether or not there would be a cold drink awaiting them should they decide to make the trip down to the machine. Therefore, the Internet of Things needs a communication medium. Obviously, it should be connected wirelessly, so it must have a spectrum plentiful to handle 50 billion mobile devices. Its coverage should be better than that in the cellular system. This means that the network is going to cover the 99.5% of devices connected. Well, now I'm going to talk about the white spaces. Uh, Weightless delivers the longest possible range for low power Internet of Things machine to machine products. The the weightless W open standard is based on a low power wide area star network architecture operating in TV white space spectrum. Weightless offers best-in-class signal propagation characteristics leading to excellent range of several kilometers even in challenging urban environments. Very low power consumption provides for exceptionally long battery life measured in years from small conventional cells and leading-edge innovation in design minimizes both terminal hardware and network hosts. A weightless network typically has a range up to 5 kilometers in an urban environment and usually significantly more in a rural setting. This depends on the specifics of the environment such as topography, building density, construction materials, antenna seating, etc. Weightless delivers the longest possible range for Internet of Things and machine-to-machine products. Many short-range technologies, including Wi-Fi, Bluetooth, ZigBee, and others, aspire to play a role in the Internet of Things machine-to-machine ecosystem. However, islands of coverage provided by short-range technologies such as Wi-Fi and Bluetooth are not an option. Um, LAN and PAN technologies cannot provide the coverage needed for applications such as automotive sensors, asset tracking, health care, and many more. Instead, they are restricted to machines connected with the home or office environments. Even in these environments, there are many good reasons why a wide area solution is preferable. For example, an electricity supply company is unlikely to accept that its meter is only connected via e.g. Wi-Fi into a home network, which in turn connects to the home broadband. Long range in building penetration. Coverage is typically more important than data rate in most Internet of Things use cases. Radio signals in the lower frequency bands go further. Weightless technology is frequency agnostic but is typically deployed in sub-1 GHz spectrum. Weightless and operates in, in ISM frequency bands, talking about 868 megahertz in Europe, 915 megahertz in the United States, for example. And weightless W operates in the TV white space, a perfect low frequency band. This low frequency spectrum enables excellent propagation at low power and without needing inconveniently large or expensive antennas in terminal devices. Superior propagation to cellular networks is a good starting point, but Internet of Things or machine-to-machine signals need to penetrate deep within homes and other buildings. Smart meters, for example, are often in basements. Coverage access to all meters in a network is more important than data rate to a utility company. Most buildings have a penetration loss for signals entering them of around 15 to 20 decibels. Techniques used in the weightless system design provide indoor coverage to machines where only outdoor coverage previously existed. The propagation characteristics make for the perfect machine-to-machine network solution. Range not only affects network performance but overall cost too. Weightless, ubiquitous coverage and extended range directly impacts on the cost of establishing Internet of Things machine-to-machine networks. As a result of the need to deploy relatively few cells, setup costs are minimized for network operators. These considerations make machine-to-machine networks radically different in many respects from traditionally telephony-based technologies. The weightless N standard for ISM and weightless W standard for TV white space spectrum meet all of the requirements for the Internet of Things, machine-to-machine communications, including range and in-building penetration. Thanks for your attention.